This video is on the method of factoring a sum or difference of cubes. If you viewed the factoring strategy video, you remember that the first question you ask yourself on every factoring problem is, do I have a GCF? So when I look at number 1, I notice I have x cubed minus 8, and there is no number in common to both of those, so I do not have a GCF. The next question I ask myself is, how many terms do I have? And I have 2. With 2 terms on the other video, we were doing primarily a difference of 2 perfect squares. Now we're going to recognize that with 2 terms, you can also have a sum or difference of cubes. So this one would have to be a difference if it is, because it has a subtraction sign. And the way to tell if it's a sum or a difference of cubes is to look at your first and your last term and see if they are perfect cube numbers. A perfect cube number is a number that factors, or a variable in this case, that factors to 3 identical factors. X cubed is a perfect cube because it is x times x times x. When I take the cubic root, I get just x. 8 is a perfect cube because it factors to 2 times 2 times 2. Again, that is 3 identical factors, so that means the cubic root of 8 is 2. So the method for factoring a difference of cubes is to take the cubic root of the first term, that's x, the same sign, that's a subtraction sign, and the cubic root of the last term, that's 2. Put that in parentheses, and now I can ignore that. I don't need that anymore. I'm just going to use the x minus 2 that I already factored out. So to find the rest of the factor, I'm going to take x and square it. I'm going to take the opposite sign, that's going to be a plus sign. Then I'm going to multiply the first times the last terms. Ignore the sign because I already decided what my sign is going to be. I'm going to multiply x times 2, and that gives me 2x. Then I'm going to take a positive sign, and then I'm going to square the last term. It's always positive because if I square a negative, I get a positive. If I square a positive, I get a positive. It's 4. And that's the fully factored form. So let me go over that strategy, or those steps again. It's a pattern that works on every problem. So I started with x cubed minus 8. I took the cubic root of the first term, the same sign, and the cubic root of the last term. Then I'm finished using the x cubed minus 8. Now I'm just looking at the x minus 2. I squared the first term. I wrote down the opposite sign. It was a negative, so I wrote a positive. Then I multiplied the first and last term together and wrote that down. And then I wrote a positive sign, and then I squared the last term. So again, it's cubic root of the first term, the same sign, cubic root of the last term. Now look at the binomial you just wrote. Square the first term, write the opposite sign, multiply the first times the last, put a positive sign, and square the last term. So that's SOP for my signs. That means same, opposite, positive. Same, opposite, positive. Same sign, opposite sign, positive sign. The last one is always positive because you're always squaring something to get it. And when you square something, you end up with a positive. Okay, let's look at number 2, m cubed plus 27. Again, first thing I check for is a GCF. I don't happen to have one, so I'm checking to see if it is a sum or difference of cubes. I've already checked that it was a difference of squares. It wasn't that. So the only other thing that a 2-term polynomial or a binomial can be is a sum or difference of cubes. There's a plus sign, so I'm checking for a sum of cubes. M cubed is a perfect cube because it has a cubic root. Any variable raised to an power that is a multiple of 3 is going to be a perfect cube. 3 is, 6 is, 9 is. Not all odd numbers, numbers that are multiples of 3. And then 27 is a perfect cube. Its cubic root is 3 because 3 times 3 times 3 is 27. I need 3 identical factors for it to be a perfect cube. So now let's just follow the pattern. I take the cubic root of the first term. I take the same sign. I take the cubic root of the last term, and I put that in parentheses. Now I have finished using the m cubed plus 27. Don't even need to look at that anymore. Now I'm looking to the m plus 3. I square the first term. that's m squared. I take the opposite sign, that's subtract. I multiply the first times the last, that's 3m. I use a positive sign, that's plus, and I square the last term, that's 9. Okay, let me go over that pattern one more time. First thing I'm going to do is check my signs. Remember, the signs are same, opposite, positive. I had a plus here. I have a plus between m plus 3. It's the same. It's the opposite. It's a positive. So my signs are right. And I took the cubic root of m cubed. That was m. I took the cubic root of 27. That was 3. Then I was finished with the m cubed plus 27. I look at just the m plus 3. I square the first term. That's m squared. I take the opposite sign. That's minus. I multiply the first times the last term here. That's 3m. Of course, put the number in front of the letter. I use a positive sign, and I square the last term. I square 3, and I get 9. I've done a sum of cubes. I've done a difference of cubes. Okay, for number 3, I've got 2y cubed plus 128. Okay, on this problem, just like every other factoring problem, the first thing I look for is a GCF, and 2 does divide into 128, so I'm going to factor out my common 2. That leaves me y cubed plus 2 from 128 is, or divided into 128, excuse me, is 64. So now, with 2 terms, remember that's how we decide what our next strategy is. We check our number of terms. First thing I look for is a difference of squares. It's not that. Then I check for a sum or difference of cubes. Y cubed is a perfect cube. Its cubic root is y. Now I have to figure out if 64 is a perfect cube. So I'm looking for 3 identical factors. Let's see if 2 is a cubic root of 64. 2 times 2 is 4 times 2 is 8. It's not, the cubic root of 64 is not 8, is not 2, excuse me. So let's try 4. 4 times 4 is 16 times 4 is 64. That's the cubic root. Remember, you can do that cubic root in your calculator under the math button. If you're not sure or you can't do that in your head, check it in your calculator. But this is a sum of cubes. So I bring down the first number that I took out as a GCF, and now the rule is take the cubic root of the first term, that's y, the same sign, that's plus, the cubic root of the last term, we decided that was 4. And now remember, I don't need that anymore. Okay, I've finished with that. Now I'm going to look at the y plus 4, and I'm going to square the first term, that's y squared, take the opposite sign, that's minus, multiply the first term times the last term, that's 4y, use a positive sign, and square the last term. 4 squared is 16. And there you go. And when you do this, that trinomial that you get is not going to be factorable. Here I would be looking for what multiplied to 16 and added to 4, and there are no 2 factors that do that. So once you have factored a sum or difference of cubes, that's your final answer. Okay, let's look at number 4. First thing I'm going to look for is a GCF. 16's factors are all 2's, and 27's factors are all 3's, so there is no GCF. Now I want to see if it's not a difference of squares because I have w cubed, so I'm going to check for a difference of cubes. Well, 27 is a perfect cube. Its cubic root is 3. W cubed is a perfect cube. Its cubic root is w. 16, however, is not a perfect cube. It has 4 2's as its factors. So I have 4 of a factor, so that doesn't work. Had it been 8w cubed, then it would have been a difference of perfect cubes, and I would have been able to factor it. But as it is, there's nothing I can factor, so it's prime. Okay. This is the method for factoring a sum or difference of cubes. Remember, follow the pattern. You've got to memorize that pattern. You take the cubic root of the first term, the same sign, the cubic root of the last term, then ignore your perfect cube, go to the parentheses that you've just written, square the first term, use the opposite sign, multiply the first times the last, use a positive sign, and square the last. The signs are always same, opposite, positive. for the three signs that you have. Good luck in factoring your sums and differences of cubes.